In these videos, I have been showing you how to use a normal distribution to calculate the probability of randomly getting a value below some predetermined number, and also the probability of getting a value above that predetermined number. Now, in this video, I'm going to address what if you have two numbers. You say, what's the probability of getting something in between those two values? And that's the point of this video here. So I've shown you how to calculate probabilities of the area to the left of something, such as the probability of z less than 0.5, and something to the right, the probability of z greater than 0.5. So how are we going to calculate an area between two values? Now, on the right side of your screen, you should see a graph that shows a normal distribution. The red area in the middle indicates this probability we want, the probability of being between -1 and positive 0.5. And the question is, how do we get that? Well, we have those two numbers. We could take the smaller number and find the probability to the left. That would be the left tail. We could get that area. Then the right value, calculate the area to the right, that would be the right tail. So we could get the values of the two tails. But then remember that the total area under the curve is 1. And so if I take my total area of 1, I subtract out the left tail, I subtract out the right tail, then all that's left, so there are the areas of the left tail and of the right tail. Again, I'll show you how to calculate these in the next few videos. But for now, we want the concepts. We find the area of the left tail, we find the area of the right tail, then what is left is in the middle, in between those two numbers. So why don't we just do that? The probability of having something between -1 and positive 0.5 will be the total area of 1, subtract out the left tail, and subtract out the right tail. All right, we have our values of 0.1587 and 0.3085 for the left and right tails respectively. So we're going to subtract those two tails out, and we're left with an area in the middle of 0.5328. That would be the probability of having of randomly getting a value with a z-score between -1 and positive 0.5. Now, we have enough information now to go back to a previous concept that we talked about back in lesson 7 on standard deviations. That concept was the empirical rule. And we said, well, the probability of a value being within one standard deviation of the mean is 68%. Where did that come from? That came from this right here. In the next few videos, I'll show you how to actually do these calculations. But you can, once you have that, you can come back here and verify that this is true. The area between -1 and positive 1 is about 0.68. So the probability of being within one standard deviation of the mean is 68%. What's the probability of being within 2 standard deviations of the mean? That's the same as saying, what's the probability of having a z-score between plus or minus 2? That'd be 95%. What's the probability of being within 3 standard deviations of the mean? That would be the same as a probability of having a z-score between plus and minus 3. That probability turns out to be 99.7%. So there you go. That's something that we talked about way back in lesson 7. We now know enough to actually show that. Okay. Now in the next few videos, I'm done showing you guys the concepts of finding probabilities under a normal distribution curve. Next few videos, I'll show you how to actually get these calculations using a z-table, calculator, specifically a TI-84, and then again using Desmos.